Okay, on page 52 in your notebook, you need to turn to that page. You're going to take down some notes. And once you complete these notes, you should be able to finish up the Math Excel assignment that I gave you the other day. Remember, it's mathexcelforschool.com, okay? So you should be able to do all 25 problems after this video. You're going to label your notes absolute value, equations, and inequalities. You should be able to fit these problems. They're not too long, but if you run out of room, use a post-it note to do the rest. So absolute value is defined as the distance from 0. And since it's a distance, when you see the absolute value and we want to solve those, so our first example is absolute value of x equals 5. When we want to solve that, we're going to always have two answers. And the reason we're going to have two answers is because if it's defined as a distance from 0, then the distance to 5 is 5, but the distance to negative 5 is also 5. So the reason absolute value problems have two answers is because it is defined as the distance from 0, and no matter if you go in the positive direction or the negative direction, your distance is still a positive answer. So for this problem, our answer would be x equals 5 and x equals negative 5. And that would satisfy this absolute value problem. And our graph would be just a dot at negative 5 and a dot at 5 because it's equal to and not an inequality from yesterday. We will see a few inequalities at the end here after we do a couple problems just to make sure we have the understanding of how an absolute value works, and we will always graph it. So for if it's an equal to, your graph will just be two dots. So we have two other examples here. Call this example 2 and example 3. And I do have a little bit difference in them so that you can see that it's not always going to be the same two numbers. So to do this problem, we would have 3x equals 6. You do need to make sure that the absolute value is all by itself. The other one will be 3x equals negative 6. You always change the sign on the number that the absolute value is equal to. If we solve this out, we'll divide by 3. X is 2. We'll divide by 3. X is negative 2. And in this case, our answer is the same number, one positive and one negative. But in our third problem, that's not going to necessarily happen. So if we have 5x minus 1 equals 9, and 5x minus 1 equals negative 9. Again, the absolute value does not change. It's what's equal to. When we do this problem, we will not necessarily get the same number, one positive and one negative. We're going to add 1. Divide by 5. So x is 2. Here we're going to add 1. Divide by 5. So x is negative 8 over 5. So you will see on this problem, 2 is here, negative 8 over 5 is on that side. We did not, this time, get the same answer for our values because it had a -1 in it also. So you do not always get the same answer. It only happens if there's no plus or minus with it. And the 9 is what changes sign because that's the distance we're looking at. So the distance could be represented by a +9 or it could be represented by a -9. Now, the rest of our problems today are going to involve inequalities. So when we deal with inequalities, we will also at the end write the answer in interval notation. When we deal with inequalities, we're going to do the same idea. So our first example is absolute value of 7x is greater than or equal to 14. And at any time in this video, if you need some more time to write or need to go back over the problem, you can pause it or you can also rewind it and play it again. So you can do that on any time on this video. So for number 4, we're going to have 7x is greater than or equal to 14. So we write down the original one. But to do the negative distance, we learned the other day that when we deal with negatives, we do switch the inequality symbol. So as soon as we make this a -14, the inequality symbol has to switch also. It's that rule about negatives. So when we have extra negatives in there, we have to switch the sign. We're going to divide by 7. So this one will be x is greater than or equal to 2. This one we're going to divide by 7. So x will be less than or equal to -2. Once we graph it, we'll know if it's an and or an or from yesterday. And we'll also write it in interval notation. Remember, we don't change this sign again because the 7 is what we divided by, not a negative. To do x is greater than or equal to 2, we're going to go to 2. Greater than or equal to 2 means we're going to color it in because it's equal to. And then we are going to shade to the right. X is less than or equal to -2 means we would go to -2. We would open circle, color it in because it's equal to, and we would shade to the left. And we do know that from yesterday that this is interval notation, so this is an or because we've got the two ends. So this would be, remember, to the left forever is -infinity with the parenthesis up to -2, and since it's filled in, it's equal to, it's a bracket, union with 2 again because it's a bracket. We'll start with 2 and it'll go positive forever, so that'll be infinity. And when we do infinities, it's always parentheses because you can never get to infinity. Number 5 is 3x plus 2 is greater than 4. So we'll write our two problems. One of them will be 3x plus 2 is greater than 4, and the other one will be 3x plus 2 will be -4, and it will be less than. So as we solve it, we'll subtract 2, greater than 2, and divide by 3. So x is greater than 2/3. This one will subtract 2, and divide by 3. X is less than -2. So we have 2/3 on this side, -2 on this side. X is greater than 2/3. So we'll put a circle, and we won't shade it in because it's greater than. We're going to shade this way. and x is less than -2, we'll do an open circle, and we're going to shade this way. So our answer for this one will be -infinity to -2, this time both with parentheses because they're both open circles, or the -2 is, infinity is always a parenthesis, union with 2/3 to infinity with parentheses. We have two last problems, and these two last problems will pretty much finish up our absolute values. So this one will be problems number 6 and 7. So we're going to go through and solve these and then graph them. So on this one, the first thing is the 3 can't stay there. The absolute value has to be alone. So we're going to add 3. So its absolute value of 5x plus 2 is less than 8. That'll give us 5x plus 2 is less than 8, and 5x plus 2 is greater than -8. Subtracting 2, dividing by 5. X is less than 6/5, or you could do the decimal version of that. The other one we're going to solve the same way. That's -10 divided by 5. X is greater than, again, we don't switch the sign because it's not dividing by a negative, -2. 0 in the middle. -2, 6/5. They're both going to be open circles. X is less than 6/5 would go to the left. X is greater than -2 would go to the right, so this is an overlap. And that means what we want, our answer, is this part here where they shade together. So this is an and when we write the interval notation for an and, the part that we care about is from here to here. So our answer would be -2 with a parenthesis because it's an open circle to 6/5 with a parenthesis. Because all we care about is the part where they overlap. So ands, remember, are always overlaps. Our last problem, we have to get the absolute value alone. And again, at any time, if it's going too fast, you can pause the video. In this case, we have to subtract the 6 first. And we have to divide by 3. And once you've done that, now you're ready to solve the problem. It'll be 2x minus 4 is greater than or equal to 2, and 2x minus 4 is less than or equal to -2. I am going to just kind of solve these rather quickly. You can pause it. At this point, you're back to just the same problem. So I apologize for speeding that up, but the video is almost out of time, and I do want to just finish up what this looks like, so you can pause it when it gets going too fast. Greater than or equal to 3 will be a closed, and again, it's just the same steps at that point once you get it all alone. And less than will go this way. So we will have -infinity to 1 with a bracket, union with 3